Today, we are diving into one of the greatest adventures humanity has ever undertaken, the incredible and still ongoing story of the Voyager missions. It's this amazing tale of brilliant engineering, profound discovery, and, well, a message in a bottle sent out into a cosmic ocean.
Everything, and I mean everything, about the Voyager mission comes down to this one number: 176 years. That is how often the giant outer planets, we're talking Jupiter, Saturn, Uranus, Neptune, all align in just the right way to make a trip like this even possible. It's a shot that comes around less than once in a lifetime.
So, I gotta ask, what would you do with a chance like that? Back in the 1970s, NASA decided to grab this celestial alignment by the horns and set off on what they called the Grand Tour. And believe me, this mission would completely change our understanding of our own solar system.
Now, the plan was just genius. Instead of trying to blast straight to each planet, which would take a ridiculous amount of fuel and time, the Voyager probes would use a technique called gravity assist. So by flying close to a planet, they could kind of steal a bit of its orbital energy, like a cosmic slingshot, and just fling themselves onto the next target. Jupiter would send them to Saturn, Saturn would pass them to Uranus, and Uranus would aim them for Neptune. Just brilliant.
This was a mission with absolutely no room for error, right? So NASA didn't just send one probe, they sent two. Voyager 1 was put on a faster track, designed to get an intense, up-close look at Jupiter's wild volcanic moon Io, and then Saturn's mysterious moon Titan. Voyager 2, on the other hand, took a slightly different path, a path that preserved the incredibly precious option to continue the Grand Tour all the way out to Uranus and Neptune. It was the critical backup. Okay, so how in the world do you build a machine that can survive for decades in the incredibly harsh environment of deep space, farther from home than anything in history? These probes were absolute masterpieces of 1970s tech. I mean, think about it. Solar panels were totally useless out past Jupiter, so how do you power them? With the steady heat from decaying plutonium in these things called radioisotope thermoelectric generators, or RTGs. They had these amazingly advanced computers for the time that could diagnose their own problems millions of miles from home, and their instruments, from cameras to plasma detectors, they were our eyes and our ears in a part of the universe we'd never ever visited before.
But Voyager wasn't just a science mission. Nope. It was also designed to be an ambassador. The team knew these probes would eventually leave our solar system entirely and just drift through the galaxy for maybe billions of years. So they decided to attach a message.
And this is it, the golden record. A team led by the great astronomer Carl Sagan put together this portrait of our world on a gold-plated copper record. It's got the sounds of wind, whales, and thunder. It's got music from Bach all the way to Chuck Berry, greetings in 55 different languages, and 115 images of what life is like on Earth. The cover even has instructions on how to play it and a map showing where our sun is located. It is our cosmic calling card. So, with the spacecraft built and on their way, the Grand Tour began. And let me tell you, at every single stop, our view of the solar system was completely and forever transformed. First stop, Jupiter. The pictures coming back were just breathtaking, but the real shocker? It came from its moons. Voyager 1 discovered active volcanoes literally erupting on the moon Io. Now, before this exact moment, we thought Earth was the only geologically active body in the whole solar system. This one flyby completely rewrote the textbooks. It proved the cosmos was way more dynamic than we ever dreamed.
Next up, Saturn. Voyager 1 flew right by its moon Titan and confirmed it had a thick, nitrogen-rich atmosphere, even denser than Earth's, which meant it was a potential chemical factory for the building blocks of life. And we also saw that those famous rings, they weren't solid bands at all, but this incredibly complex system of thousands of tiny little ringlets, all braided and woven together by tiny shepherd moons.
With Voyager 1's main mission done, Voyager 2 pressed on, all alone. In 1986, it made the first ever visit to Uranus. And what it found was just bizarre. An ice giant tilted completely on its side, with a magnetic field so wacky and offset that it kind of corkscrews through space as the planet spins. We found 10 new moons and 2 new rings we never knew existed. And the final planetary stop was Neptune, way out there in 1989. You think it would be a quiet, cold world, right? Wrong. Voyager 2 found a planet with winds faster than the speed of sound and a huge storm system they nicknamed the Great Dark Spot. And just like Uranus, its magnetic field was wildly tilted, and it had these faint partial rings that looked more like arcs. So one of Voyager's really important jobs was to study each planet's magnetosphere. What is that? Well, you can think of it as a magnetic bubble that a planet creates, and it shields it from the constant blast of particles shooting out from the sun. These bubbles are also incredible particle accelerators, and they're what create amazing things like Earth's auroras.
And Voyager showed us just how massive these bubbles can be. I mean, just look at this chart. Jupiter's magnetosphere absolutely dwarfs Saturn's and our own. In fact, if you could actually see it from Earth, it would appear bigger than the full moon in the night sky. That makes it the single most dominant structure in the entire solar system, besides the sun itself. Wow.
Okay, so the data Voyager collected, it's not just some historical artifact. Its legacy is so huge that scientists are still using it today to make brand new discoveries. Let's look at one amazing example, how Voyager helped solve a huge mystery about Jupiter's seasons. We get seasons here on Earth, sure, but how do they work on a planet that has no solid surface? A planet that is basically all atmosphere? For decades, we really didn't know if Jupiter even had serious seasons. But thanks to Voyager and another mission that flew by 2 decades later, we finally got our answer.
Here's how they cracked it. Scientists had 2 perfect snapshots of Jupiter's atmosphere. First, Voyager 1 flew by in 1979, right during Jupiter's northern fall equinox. Then, in 2000, the Cassini spacecraft zipped by during the northern summer solstice. This gave them a perfect before and after picture, 21 years apart.
So here was the crucial clue. They used specific chemicals in the atmosphere like tracers. They looked at one, ethane, which is really stable and, well, it didn't really change much. But another one, acetylene, is very short-lived. And its pattern changed dramatically. In 1979, it was spread out pretty evenly, but by 2000, it had dropped off significantly near the poles. That short-lived acetylene, that was the smoking gun. It revealed a massive circulation pattern in the atmosphere, all driven by the changing sunlight between the seasons. The conclusion was undeniable. Jupiter's atmosphere is an incredibly dynamic place that experiences powerful seasonal changes. And just like that, a mystery was solved, all thanks to data collected 21 years apart. The planetary tour was over, but Voyager's journey was really just getting started. Now it was time for the final act, the incredible leap into interstellar space. Before they shut down the cameras forever to save power, Carl Sagan asked them to turn Voyager 1 around one last time. And from nearly 4 billion miles away, it took this picture. That tiny point of light just suspended in a sunbeam, that's us. That's Earth, the pale blue dot. It's an image that gives you this profound, humbling feeling about a real place in the universe.
For years, the probes just kept flying outward, heading for the boundary where the sun's influence finally gives out, a place called the heliopause. Then, in 2012, Voyager 1 crossed that boundary. It became the first human-made object ever to enter the space between the stars. Voyager 2, on its own longer path, followed it in 2018. Right now, at this very moment, they are out there, directly sampling what the interstellar medium is actually like.
Today, both Voyager spacecraft are still working, still beaming back precious data from interstellar space, from over 14 billion miles away. They're going to continue to drift through our galaxy for eons, long after our civilization is gone. They are humanity's silent ambassadors, carrying a message from a small, distant world. And that leaves us with the ultimate question: who or what will one day find it?